Hi there, here's a video on logarithmic equations, which you can reference in Chapter 7, Section 3 of your textbook. First of all, let's take a look at how to transform an exponential equation into a logarithmic equation, or vice versa. They are very much related, and it's not that hard to switch back and forth. Exponential equation, remember that's going to be a base b raised to the x power equals a. And remember, b has to be greater than 0, and it cannot be equal to 1. As seen here in green. And so if we want to switch it to a log, we'll have log base b of a equals x. So notice that the log is equal to what used to be our exponent. So the log solves for the exponent that gets us from base b to a. So in these examples, let's start off by writing these in logarithmic form. So on 1a we have 9 to the second equals 81. Yes, we know that's true, but we're wanting to rewrite this as a logarithmic equation. So I'll have log base b, so remember b to the x, so my base b is 9. I end up at 81, and my log is equal to my exponent. So the exponent that I put on the 9 to get to 81 is 2. On 1b, we'll have 3 cubed equals 27. Let's rewrite that one as a log. So we'll have log base b, so base 3. We got to 27, and 3 to what power gets me to 27? Well, that's 3. And one more. We'll have log base x to the first equals our exponent of 0. So in each of these, our log was equal to our exponent. Now let's look at switching them the other direction. So on example 2a, we have log base 10 of 10 equals 1. So if my base is 10 and my log is equal to my exponent of 1, that will be equal to 10. And I always check, does this thing make sense? Is 10 to the first power equal to 10? Well, that's true, so we did a good job there. All right, so log base 12, so my base is 12 of 144 equals 2. Well, my log is equal to my exponent of 2, so I get that is equal to 144. Does this make sense? Is 12 squared 144? Yes, it is, so we did a great job. And then one more, log base 1/2, so I have 1/2. Log base 1/2 of 8 equals -3. My log is equal to my exponent of -3. And that is 8. So this is wanting to know, is 1/2 to the -3rd equal to 8? Well, yes, because that's 2 to the +3rd, and 2 cubed is 8. Just a couple of things to note. We do have a couple of special properties of logarithms. These are really things that you already know, but just putting them in terms of logs. So if we have log base b of b equals 1, remember that if I rewrote that as an exponent, we will have b to the first power equals b. So all this is saying is if your base b of that number is the same thing, so if you have a b of b, that means it equals 1 because anything raised to the first power is itself. So log base 10 of 10 equals 1 because 10 to the first power equals 1. Or if you saw log base 2 of 2, that would equal 1. So that's just saying if you have a log of base b of itself, you'll equal 1. Not that hard. Okay, also, if you have, we have this property called logarithm of 1. So if you have log base b of 1, that will always equal 0. So it doesn't matter what your base is. If it is at 1, then we'll say what is that equal to, if it's equal to 0. So if we have base b raised to the power of 0, that equals 1. So all it's looking for is saying if this number right here, if that's a 1, then it's going to be equal to 0. Now in case you were wondering, well, why can't log base b of 1 equal 1? Why is log base b of 1 not a possibility? Say we were trying to figure out what that is. Well, what to the first power equals 1? Well, what if 1 to the first power equals 1? So why is it okay? Why do we know that that this will be equal to 0 instead of 1? Well, that's because whenever we were looking at the exponents of b to the x, in order for it to be exponential, b had to be greater than 0, and b cannot be equal to 1. So the same rules apply. That's how we know if we have log base b, doesn't matter what the value for b is, of 1, that it will not be equal to 0. Or it is equal to 0. Sorry. All right. Anyways, that's all we were saying there. Okay, one more thing here. A logarithm with a base 10 is called a common logarithm. If no base is written for a log, the base is assumed to be 10. So that's just kind of like whenever we had square roots or cube roots or fourth roots or whatever, if a number wasn't written there as your index, we understood that to be 2. Well, for logs, if the number isn't written there, so log base 2 or a log base 5, well, if the number is not written there, the base, it is implied that it is the common logarithm, which it would have a base of 10. Now we can also use mental math to evaluate some logarithms. So let's look at a couple of examples here. So we have log, this is a common logarithm. The base is not written there, so that means that it has a base of 10. So if we have log base 10 of 0.00001, we're trying to figure out what that is equal to. Well, in other words, what I'm trying to figure out is 10 to what power gives me that 0.00001. Let's rewrite that as a fraction and see if that helps. So 10 to what power is equal to 1 over, so this would be tenths, hundredths, thousandths, 10,000ths, 100,000. Oops, 100,000. So we know that this exponent will end up being negative because it's 1 over. So 10 to what power gives me 100,000? Well, I know that 10 to the 6th power, 10 to the 5th power is 100,000. So to get 1 over that, that means my exponent is negative 5. Therefore, this log is equal to negative 5. On this next one, we can do a very similar thing. So let's switch that back to a fraction. So we'll have log base 25. This is 4 over 100. Well, 4 over 100 is the same thing as 1 over 25. So 25 to what power gives me 1 over 25? Well, that's just equal to negative 1. So that would be our answer there. All right, that's it. Let me know if you have any questions, and I'll see you later. Bye.